Hey, everybody. Great. Yeah, so why don't we just feel free to put in where you're from and what grade level or levels you teach, or if you teach teachers, yeah, so that we can get to know each other. Wow, a lot of littles, huh? K2? Great. Well, welcome everybody. So I guess this will work. Yeah. So I do have some audience participation. So I guess we'll do the participation in the chat, since that seems to be how it works with Hopin. It's a little weird for me that I only see myself and don't see all of you. That's okay. I will handle it. Okay, let's see. So I'm going to try to share my screen.
Hi, Diana.
Hi.
Hi, I'm a moderator for you, so I will be turning my camera off, but I will have the notes up and be taking notes in there. And then
Great.
Just let me know if you need anything. My name is Venus Casab, by the way.
Okay, so I tried sharing. No, that didn't work though.
To share your screen?
I'm trying to share my screen.
So on the bottom, you should have a little, looks like a little computer monitor. That should allow you to share.
Yeah, well, I did that, and then I clicked on what window I wanted, and then I click on share.
And it didn't work?
It doesn't do anything.
Let me see something. Tell me if you could see my screen.
Yeah, I see your screen.
Okay, so I'm wondering if it's not working for you. Let me contact tech and see what they can do. Okay, unless you want to try it again.
Okay, so it worked for a single tab. So we'll see.
Okay. All right, great.
Let's see if that works. Okay, great. Welcome everybody. All right, let's see. Okay. All right, so I'm here to talk about elementary CS integration, and just to sort of let people know where I'm coming from and my perspective. I just wanted to give sort of an introduction that ends up driving my philosophy and all of my work in how I view computer science. If we look at computer science historically, for a really long time, it was a niche field, with some people in it, and it seemed to be a good field, but not a lot of people in it. And then it became sort of, okay, this is really a career. Okay, this graph is misaligned. Those boxes, I can see that when I imported it into Google, it's misaligned. But anyway, it became a real career, and now it's sort of, some people call it the fourth R. It's gotten to the point where if the students who are in elementary school now, especially by the time they graduate, if they don't have any coding skills whatsoever, that will limit or make them less attractive for many, many jobs way beyond. This is no longer about making computer scientists, right? This is about making it so that people can use coding in all of their in many careers, not every career, but in many, many careers. And so that difference between sort of, oh, we're just trying to convince people to be computer scientists, and oh, actually, it's a huge percentage of the population that can benefit from this professionally. And what we found over the years, this graph on the left is the saddest graph, I think, which it shows over time as women enter the workforce. It shows the percentage of bachelor's degrees that were awarded to women. And you can see that, you know, pretty much across the board, as more and more women were getting college degrees, they were getting higher percentages in different fields. And these are STEM fields specifically. Oh, I guess social sciences is in there. And so most of the lines are mostly increasing as time goes by. But you can see that there's this heavy, heavy pink line that goes up, and it peaks in about 1984, and then it goes down. And that's computer science. And so that's when we recognize, you know, when we look at this, we know something's wrong. Something is wrong in our society, or something is wrong somewhere, that as women enter the workforce, they're not entering this field that is becoming increasingly important in our daily lives. And we can see this with AP tests on the right-hand side. These were 2010 to 2011, what people were taking the AP test in California. And what we see is on the left-hand side, those two pie charts are the mix of ethnicities in California on the top. Latinos are half of the population, African-American 7%. And then, of course, female and male are fairly evenly split. But we can see that of the students taking the AP test, you know, only 7% Latino, 1% African-American. And we can see that it's predominantly male. So the number of students either getting opportunities or being encouraged to take those opportunities is not at all commensurate with the population that exists. Now, it's 10 years later now, and luckily some of this has gotten better, but this is really what drives me. And so when we look at computer science instruction, there are sort of two somewhat competing thrusts. You know, one is to really increase that engagement through fun, culturally relevant, you know, sometimes using physical computing, things that can tie it to what people already do and already love, so that they can see that computer science and coding is not this like crazy other thing that only some people do, but to try to connect it so that they can feel identity and they can enjoy it and really feel like, oh, this is something I could do. And then a second tactic is sort of to make sure that all the people have opportunities, to increase access by putting it in formal learning. So a lot of the engagement happens in informal learning spaces, but we know that those aren't equitable opportunities. And so there have been a lot of initiatives to try to bring it to more people. And all of you out here are part of that. And I love that you're introducing computer science to your schools. So in computer science instruction, there's a lot of different ways you can go about it, right? You can go about, you know, with these sort of targeted puzzle-based ones that are individual skills, and they are engaging and they're easy to teach and easy to assess. And that really helps with access, because that means that a lot of students can do this easily. It's largely on your own, and it is wonderful in so many ways. And then there's sort of the other end of the spectrum, which is building open-ended, you know, self-driven, engaging projects that build identity, confidence, and agency. But it's really, really hard on the teaching side to teach this and to assess it, because what the students produce is so different. Some kids are going to propose something that they're never going to be able to code. And so as a teacher, it's just really challenging, but yet really rewarding. And so this is often more in the space of informal ed. And so what I and my group has been trying to do over the past 15 years is trying to figure out, how can we get the best of both worlds? How can we provide enough structure so that teachers feel comfortable and students are learning and we can do assessment? But how can we keep it open-ended enough so that we can still have the advantages of those, you know, building identity, confidence, and agency? So it's really trying to strike this balance. And so that's really where my group sits. So, okay. And so we've done a lot of things like I said, over the past 15 years. My group has built curriculum for informal learning as well as formal learning. We've looked at learning trajectories. What are the, if you take the topic loops, what does that mean? How can we break that up into tiny parts so that we could teach part of loops to a second grader or to a kindergartner, right? What aspect of loops, what aspect of these different things, what aspect of conditionals is appropriate for young children? And actually, we're doing this now for quantum computing. So for quantum computing, what would be appropriate for a third grader? Clearly not writing a quantum program. And then we've also created learning strategies to help students. And then I'll talk about this more later. And for quantum computing, we're also doing games and zines, because quantum computing is very much on the side of, we're just at the engagement part. Like, we're not going to be informal learning at this point. We want to do informal learning of the very first insights, just to build engagement and make people feel like it's something they could do if they wanted to. Okay, so I was asked to talk about integration. And don't worry, I'm going to try to make this, when we get to the single activity integration approach, I'm going to make it interactive so you all can participate. I can't imagine being on a Saturday and just like having someone talk at you all day. So I'm going to try as hard as I can to make it something we can do a little bit together. So I'll just go over some general CS pedagogical approaches, just for, I don't really know exactly where all of you are in how much you know about CS pedagogical approaches. So I'll just review some of them. And then what we'll do is we'll get into single activity integration approach, and I'll talk about an approach that we're taking and invite you all to participate in it. And we'll all design a single activity. Integration activity. And then I'll also, if we have time, I'll also talk about how we went about a year-long integration where you have many activities that are strung together in an integrated way, and some examples of that. Okay, so when we're looking at the goals for CS pedagogy, it sort of meets what I was talking about earlier. There are really two aspects. One is supporting students' academic needs, and one is supporting students' engagement or identity building needs. And so we try to do that for both. And so one thing that we use, we didn't make this up, but we use it, is called the use, modify, create progression. And so what that essentially means is that whenever there's a new concept, instead of introducing it outside of the computer and then having them build something from nothing, what we do first is we introduce it outside of the computer, tie it to daily life, and then we give them a project that uses that concept in code, so that they can learn from that example and see it in action. And then we ask them to make small modifications so that they actually engage with that code in a meaningful way. And then after that, we then let them do an open-ended project, more open-ended project that has, parameters to encourage them to use that new concept that they just learned, but allows them to do that engagement and identity building and the like. Okay. And so what we find, though, is if you give somebody example code, especially a young child, it's like, well, they don't necessarily know how to learn from that. Like, sure, they'll run the program, but how do they learn from that? And so we created this tip and see learning strategy that familiarizes students with the example code and teaches them how to go from just running it to actually learning from it. And so it helps them focus on the relevant new portions and gives them concrete things. And this is specific to Scratch, actually. So if you're using Scratch Junior, it might look a little bit different, but maybe not, because I think Scratch Junior is also set up with sprites and events. So anyway, it both helps them navigate the interface and also gives them sort of things that they can do. Okay, and then the other thing that we care about as curriculum designers is to make sure that we help the teachers and help the students. And so we want to make sure there are clear instructions, checklists for completeness, especially on the upper elementary and middle school end. And then we actually provide auto graders for students and teachers so that you can check to see if you're finished with the required elements of the projects. All right, so then on the other side of it is the engagement and identity building. And so one thing that we did in our curriculum, Scratch Encore, is that each of these columns is actually one concept. And it's sort of like a choose your own adventure. You can, as a teacher, you can decide, well, I have these 3 choices of the learn by example activity, right? Learn by example activity is when you're giving them sample code. And so we have 3 choices for you to choose from, and you can choose which one you think your students will like the best to try to connect with them better, or with other things going on in the school, right? So we have a Day of the Dead one, and so if it's around Halloween, Day of the Dead, then you could actually use that in your classroom. And then constructionism is a big pedagogical approach that's popular in computer science. It's an extension of constructivism, right? Constructivism is about connecting, that all learning connects to prior knowledge and prior learning, whereas constructionism goes a step farther to that, and says that if you're doing personally meaningful self-directed projects, then that learning, you get deeper learning. And also if you're displaying whatever you're making in a public forum, then that also increases learning and increases motivation. And so this is very similar to sort of science fair thought, right? In science, if someone's doing a science fair, everybody's choosing their own project, they're doing something similar, and the fact that they're displaying it for people to see gives them incentive to sort of polish their project a little bit more. And so these can be done in culminating projects to do a little show and tell or gallery walk in the classroom. Okay, so that's just sort of standalone CS. For this session, we were asked to talk about integration. And so I wanted to, so this is one of the ways people look at integration. So normally we have just disciplinary, all the different skills are being taught in the different classes. One thing you can do is a multidisciplinary approach where you take a common theme, say Egypt, and maybe you'd be reading about it in your history class. You would be practicing your reading comprehension techniques for English language development. Maybe you would have a science module that would look at how the pyramids were built, and then maybe in mathematics you would study the geometry of the pyramids, and then maybe in computer science you would code up a project at the end that showed off your knowledge that you learned. Okay. Whereas in an interdisciplinary project, you would actually have a single thing you're doing, like building a solution for water conservation or something. And so you would actually, to do that single thing, you would need to get some math skills, you would need to learn some of the science, and so it would be more tightly coupled because your culminating project requires multiple skills. Oh, I'm sorry, that's transdisciplinary. And so interdisciplinary would be when you're actually teaching them at the same time and introducing them at the same time. Okay, so some examples of interdisciplinary are, say, programming a model for virus spread or programming a habitat simulation. So these are examples of computer science plus science, and Project Guts has some great, well, I guess middle school modules for that. Okay. The challenge is the balance. The challenge with interdisciplinary is that you're teaching both skills at once, and so students are using new skills at the same time, and that can be really high cognitive load. So, so when we've gone about our interdisciplinary, we've actually made sure that we never introduce skills from two subjects at the same time, because we don't want students wrestling with two new skills at once. Okay. So our practical model for integration is what I'll call unequal integration. So I choose which one has already been introduced, and then my integrated activity is reinforcing what was already introduced in one while introducing the new thing in the other. So I never introduce two new skills at the same time. Okay? So what we have is we have a subject one lesson that's already happened. So I have a subject, they've just learned something in it. And then I build a second lesson around it that uses subject 2 and introduces a new skill in subject 2 so that we can practice a skill that we already learned in subject 1. So that's sort of how I view, which doesn't quite fit into any of the integration models above, but that's what we've done in our work. Okay, so we're going to be ready for your participation. Hopefully you haven't fallen asleep yet. So we have this new project called Harmonizing Encore. So Scratch Encore is our curriculum that I showed, that for each technical project, we have 3 choices. But what if you're a teacher and you don't think any of those 3 choices are really going to resonate with your kids? What we want to do is we are going to design resources that would help you create your own example project that your students can use to introduce that new skill in computer science. So we're going to hold the computer science technical material constant while bringing in some other subject to be reinforcing. So it'll be new computer science material, but it'll be exactly the same material as a project we already have. And we want to change the theme to be whatever you're studying. Okay. So like I said, we're using use, modify, create. And so what we're doing is we're replacing this example activity, because this is where we've given them code, we've given them a project, and we want it to be fun. The create, they're making themselves. So we don't have something we give them, but we do give them that example code. Okay. So what I want you to do is to choose a topic that you want to integrate with the computer science today. So it's nice for it to be meaningful to students and related to the academic learning. So a few ways you can go about this is things that you think your kids care about that aren't academically related, like Fortnite, Pokemon, hobbies, interests, whatever. Or you could do something that relates to the cultural background of your students. Or you could think of something even more local to your school, to your town, to your county, like events that are happening, a celebration, maybe careers that are really common in your area. If you're in a farming area, or if you're in the city, that might look different. Or look at the geography. Do you have a lake next to you? Do you have a conservation area? Do you have mountains? Like, I guess not many mountains in the Midwest. But anyway, do you have plains? Lots of corn growing around you. So whatever it is. So those are some ideas. And I'm going to give you 3 minutes to decide what you want to pretend today that you're going to create an integrated activity about. I will set a timer. All right, so this is fantastic. The 3 minutes is up. So I just want to remind, so there are sort of two ways to think about this. If we're thinking about things that the kids will code, then that would be the create project. So that also is wonderful. And I think, create projects can be completely open-ended, or they can be partially open-ended. So asking them to code something about their animal is a great idea, or a career of their choice. Great idea for a create or culminating project. What we're going to do is think about the project that we are going to code and give to them as an example that they'll modify. But animals and careers, we can also do that. Okay, so we've got two in animals, wonderful. So if everyone can just sort of put what their theme that they're going to do, and all themes are wonderful. So we've got 2 themes now already. And famous person. Okay, so and remember that we're not thinking about this as the thing they're going to research and code. It's that you would provide them something. Like I said, having them research and code something is also wonderful. It's just not what we're doing at the moment. So famous people may, because okay, plants, great. So we've got animals, plants, careers, and famous people, wonderful. Okay, so now we'll do the next step. Okay, so we shared topics. They all look great. And so what I'm going to do is I'm going to show you, okay, I have to stop sharing and share a different tab. So just a second, let me stop sharing. And then I will share a slightly different tab. Okay, so what I'm showing you is our animation module. So let's imagine that you want to integrate this theme you thought of to put it into the animation module. And so basically you're going to make a code for them to play with in the use modify, and then they're going to do that thing that you talked about. Oh, they're researching this thing, and they will make their own thing for the create. But we're working on the thing that you're going to make for them. And so what I've done here, or actually my student did it, and she did an amazing job, is this shows in action our 3 existing projects for the animation module. And you can see that they all have a few attributes, okay? More specifically, they each have 2 sprites that are moving across the stage using animation. And then there is a single sprite that animates in place, okay? And so, and they all use the same code. They all use, sure, maybe the parameter is different. None of these are waiting 1 second. It'd be like 0.1 seconds. So there's some in place, right? Repeat loop with a wait and a next costume. And then the ones that are moving across the screen have the same code, except that the move 10 steps makes them go across the screen. So they're also in a loop of moving. The wait block does the timing, how fast it goes, and then the next costume is what makes it move so that it looks like it's actually, there's motion there, okay? So the next step is to think about what would yours look like. So you've already chosen your theme. You have to choose what is your background going to look like? What are your 2 characters going to be that are moving across the screen? And what's your 1 character going to be? And in the Dragon Boat Festival, I believe there's an audience that isn't shown here, or maybe the flags move. So anyway, there's also something that is in place motion. So I'm going to give you 5 minutes this time, because it might be a little bit harder, to think about what's your background going to be and what are your 2 sprites that are going to move across the screen in some way. They could move up, they could move whatever way you want. And then what's your sprite that's going to be in place motion going to do? So I will set my timer again for 5 minutes. And feel free to chat in the chat. You know, it's always hard to do audience participation when we're not in person. All right, this is great. Yep. All right, wonderful. Does anyone else want to share their ideas? These are all wonderful ideas. Okay. All right. So hopefully that gives you a little bit of an idea. If you weren't already integrating your own ideas of a way that you can create a single activity that goes with an existing curriculum. Okay. And so for our curriculum anyway, over the next year, we'll be developing. So I sort of stepped you through it here. There's sort of more to it. And so we'll be creating those resources that make it easier for you to sort of swap out our projects with your own projects. Oops. Oops. Try that again. Okay. Okay. Okay, so I think what we've found in our work is that it's a lot easier if you're replacing the theme of an existing lesson so that you don't have to design all of the technical content, the computer science technical content, at the same time as you're trying to design the X, whatever you're integrating with content. And so I think that holding one of those constant can really work well. And so, like I said, and if you're interested in being part of this research, feel free to send me email. We have opportunities for teachers to be paid to be involved. Okay. All right. So then the last thing I wanted to do is just go through a different approach we took, which was for multi-activity integration approach. So this is called action fractions. And so this is when you're looking at doing this for a whole year. And so you need a learning arc for both. You can't just have a single activity. And so instead of holding the computer science curriculum constant, we actually held the mathematics constant. And so we targeted fractions because fractions are one of the most difficult, the most challenging concepts for elementary school students. They're highly correlated with success in algebra, and success in algebra is highly correlated with college, going to college. So that's why we targeted fractions. And so what we wanted to do was create CS activities that introduce CS concepts, but are really supplementing the math learning. So in essence, on the inside was everyday mathematics lessons, and then we were trying to create CT lessons that would go along with those and reinforce the mathematics and introduce the new CT content. Okay. So what we essentially did was we said, okay, well, we're going to keep all of the math. We're not removing the math. But what we're going to do is every once in a while, we would jump over and introduce some CS concept and have an activity that introduces it while reinforcing that math. And we have approximately one CS activity every 2 weeks, but it's only on fractions. So sometimes it's once a week, and then sometimes it's less often. And then for the CS part, we were guided by CT learning trajectories that identify very individual learning goals, as opposed to like, oh, they have to learn all about loops. It's like, oh, they have to learn that repeating things can have a cumulative effect, or the fact that instructions like step 3 times do the same thing as step, 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 the sequence of 3 times. Okay. So I'll just show you a little bit about what that ended up. Oh, and so I'll say our process was literally to go through every lesson of everyday mathematics and keeping in mind where we were in the CT learning trajectory. Say, okay, is there any content in this 2 weeks that we could do a lesson on that connects CT-wise to the lesson we did 2 weeks ago? So it's like in the beginning, we were just doing sequence, and then we introduced loops, very simple loops, just repeat loops. And so we just very gradually introduced things. In the second year, we introduced conditionals and variables. So we just very gradually introduced CT concepts, and we did multiple activities on the same CT concept so that we weren't having them go really quickly in CT while they were trying to learn these math concepts. Okay, so I'll just give you 3 examples of activities we made. One is fraction circles. So we created custom instructions for Scratch that basically you have your setup, which would clear everything And then you would choose a piece, a fraction circle piece. So this would choose between these pieces that are different colors and different sizes. And then you would add pieces. So it was basically a virtual manipulative. And this is showing fraction unit addition. Okay. So that's the project they're given. The question is, what do they do with it? So this was like a math worksheet. They were introduced to it. I didn't show that part of it. They would play with it and answer some questions about the code and answer questions about what they saw on the screen so that they could familiarize themselves with it. So that was the use, and then this is the modify. So we're asking them to use that code and make changes to the code and so this one is going to make 2/3, and so then they're supposed to draw what they see, write the number sentence, and write it out in words. So some of this is just, the words in the number sequence, that's just straight math. But then this relationship between, this 2/3 and the picture, that could be straight math too, but this code can serve as a check, because then they code it and they run it. And then in each row, we give them different parts, and they have to fill in the rest. And so there are different relationships that are hopefully connecting in their minds between the code, the picture, and the different parts of the math. Okay. Then we have a later one that's more flexible fraction addition. And so we have Avery on this boardwalk with the different animals. And so Avery can walk any fraction amount forward. And that translates to a number of steps for us. So we have a calculation that does that. And so then what are the students asked to do? Well, first they're asked to figure out where each of these things are on the number line. This is from 0 to 1. And so they're asked to figure out the fractional value. So they use that by playing around and having her walk different places and seeing if she's in the right place. And then we give them challenges, addition challenges in fraction. And the way you can check if you got there, is whether I got to the penguin. So it's sort of a fun way for them to check their math instead of just doing dry fraction addition. And that's also sequence, right? That code was, from a computer science perspective, no more difficult than the previous code. So we're reinforcing the same concepts in CT a lot so that we can prioritize the math a little bit. Okay, and then here's one in the 4th grade that was looking at fraction equivalence of different ways that you can solve the same problem. And so basically what this is this is a simulation of cutting up pizza and handing out pieces. And so they have to decide what the fraction is going to be for the pizza. And then they have to find a distribution algorithm to give it to person 1, person 2, and person 3, so that we distribute all of the pizzas. And so this is where they're using loops, repeat loops, and they're learning about, if you look at this code that is given, the give piece to person 1 is inside the repeat loop, and the give piece to person 2 is outside the repeat loop. So it's going to give person 1 2 pieces, but person 2 will only get 1. So it's teaching them sort of where the blocks go, like within the repeat loop, after and before the repeat loop. Okay, so that's all I have. Let's see. Yeah, any questions? Oh, okay, question, you talk about CT. Yeah, so the distinction between CT and CS, CT can be off a computer, but when we're doing coding, that's also using CT. And so we do have off-computer activities as well as on-computer activities. So it is computational thinking, but it is also coding. So it's both computational thinking and computer science. Yeah, and any other questions? Well, let me just put my email in the chat if you ever want to email me. Or you can use my. And then if you want to, so we have a website, canonlab.org, that has you can get, all of our stuff is free. We have full, but we don't have a Scratch Junior. Marina Bears is the best one to get a curriculum for Scratch Junior. We have Scratch curriculum. We have one that's designed for like 3rd through 5th graders, and then we have another one that's more for 5th through 8th graders. And so you're welcome to any of those free resources. We have full student resources, full teacher resources. So I'm Diana M. Franklin 1 for Twitter. And then I'm on Facebook more. I don't follow Twitter all that much, but I guess I get notified over email. So I'm just, I don't know. There's no, for Facebook, you just look up my name and find my picture. My picture is with my husband and my daughter. My daughter is like putting bunny ears between us. Yeah, well, thanks everybody for coming. I guess we'll be kicked to the main session soon, but I find it very awkward to do a in person when I can't see any, or I mean the virtual where I can't see anybody. So I hope everybody was okay with it. Oh, sorry. Yeah, and like I said, I do write grant proposals, and I just did one for rural schools. If it gets rejected, I'll be doing it again. So if teachers are interested in working with me, love to work with everybody.